This is a video on section 6.4 in our geometry text that deals with relationship of triangles and their angle measure with respect to finding the largest or smallest side in a triangle based on the angles of sides given, and also determine whether or not a triangle is going to be formed. So this diagram is not drawn to scale. If we have triangle ABC, and I give you these three side lengths, the question is, which is the largest angle, which is the smallest angle? Well, across from any triangle, across from the longest side is going to be the largest angle. So in this case, angle B is going to be the largest angle in this triangle. And across from the smallest side is going to be the smallest angle. So angle C is the smallest angle. And of course, the middle side, which in this case is 8, that's going to cross from the middle angle. So across in a triangle, across from the longest side is the largest angle. Let's see if we think the converse of this is going to work as well. So suppose I give you two angle measures, 60 and 50, triangle DEF, and I ask you to find which is the longest side. Well, it seems reasonable to find the missing angle. So since the triangle has all three angles summed to 180, our missing angle is 70 degrees. So once again, it's not drawn to scale, but it seems plausible that if across from the longest side is the largest angle, well, therefore, if we want to find the longest side, we look for the largest angle. We go across from it. So therefore, side EF is the longest side. And the shortest side we expect would be across from the smallest angle. So in this diagram, since 50 is the smallest of the three angles, the side DE is the shortest side. A problem that's related to the concept that we just mentioned, but much more difficult, is when we have two triangles that have a common side. So if I ask to find the shortest side in this figure, well, overall it's a quadrilateral, but it's two triangles joined. So we have a total of 5 segments that are possible. There are 5 different sides in these triangles. 6 total sides, of course, separately, but 5 different sides. So which is the shortest side? Well, a good starting point is to find the missing angle. So 60 and 50 is 110, so this angle is 70. And the bottom triangle, 80 and 40 is 120. So therefore, that angle is 60. It is not sufficient when you have two overlapping triangles just to look at the smallest angle, in this case 40, and say, well, across from it is the shortest side. That's not true necessarily in the overall figure. The best way I have students do this is to pick one triangle, either the top one or bottom one, it doesn't matter, and I may pick up 3 numbers that represent side lengths. So let's say there's a a 1-inch side, a 2-inch side, and a 3-inch side. And I know actually this can form a triangle, as we'll look at later, but just to make the numbers easy. Let's say, looking at the bottom triangle. Of those 3 sides in the bottom, if the side lengths were 1, 2, and 3, where do we place the 1, 2, and 3? Well, we know from before that across from the largest angle is the biggest side. So in the bottom triangle, across from the 80 must go the 3. The middle angle is 60 in the bottom triangle, that would be the 2. And the smallest angle is the 40, and that would be the side length of 1. So just looking at this bottom triangle, well, of sides 1, 2, and 3, if we want the shorter side, we know it can't be the 2. We know it can't be the 3. So those 2 sides are out of the picture. We only have 3 remaining sides left. So therefore, I'm just now going to focus on the top triangle. Well, since I've already identified a side length of 1, by reflexive property, if BC is one of the bottom triangles, also BC is one of the top triangle. So we're going to say that's 1 inch. Well, just looking at that top triangle, well, what do we know? Well, we know the biggest angle is 70. So across from it, that means BC is the longest side in that top triangle. Well, that means the other 2 sides have to be smaller than 1. So I can't say what these numbers are, but we know that 50 degrees is smaller than 60 degrees. So this side over here has to be less than the side over there. So making up numbers smaller than 1, I'm going to say, let's say 0.5 and 0.8. Without even making numbers, we knew right off the bat 50 was the smallest angle in that triangle, so therefore across from it has to be the small side, so 1 is no longer BC, that was 1 is no longer in contention, therefore the shortest side is AB. I recommend you do the same thing, pick on your own, pick the top triangle, put those numbers 1, 2, 3 in the correct spot, and see if you can similarly cross off sides and come to that same conclusion. No matter what way you start, AB for this problem is going to be the only and the correct answer. And then one more thing to finish up with is looking at, if I give you 3 numbers that represent side lengths in a triangle, can they form a triangle? So if I give you 2 inches, 3 inches, and 7 inches. A lot of students at first say, sure, any 2 sides, you can always form a triangle, third side, I'm talking with no overlap. Make it even more to show this one's not going to work. Let's make it 70. Well, think you have a 2-inch side, and you somehow connect the 3-inch side. Well, you could connect 3 inches maybe there. Well, the third side, no way that can be 70 inches. Or let me put the 2 back, and let's do the 3, trying to elongate it out much more this way. Well, if you might connect that, it seems like there's no way that's going to be 70. So the answer to this is no. There is no triangle possible with those 3 sides. And the easy way to do it is if you take the 2 small sides. So if you take the small side and the middle length side, as far as length of measure, if the sum of the 2 small sides in a triangle, if it's bigger than the longest side, then a triangle is possible to be formed. So before, or if I gave you 2 inches, 3 inches, and let's just do 7 inches, is that triangle possible? Well, the work I want you to show on that is, does 2 plus 3, the 2 smallest ones, question mark, is that bigger than the longest side by itself? Since 5 is not bigger than 7, right, that's no, therefore the answer is no triangle is possible. And it must be greater than. So if I gave you 2 inches, 4 inches, and 6 inches, the answer to that is still no, because 2 plus 4, question mark, is it bigger than 6? Since 6 is not bigger than 6, so no, no triangle. So if I give you 3 numbers in a row, it's really easy. So if I give you 5, 8, and 12, does that form a triangle? Well, you just add the 2 small ones. Question mark, is it bigger than the third one? 13 is bigger than 12, so yes, a triangle is possible. The one thing you have to watch out for is make sure that the side lengths are in order from small to big. If not, you can get an erroneous answer. So for example, suppose I give you 14, 9, and 3. You don't want to say 14 plus 9 is bigger than 3, which is clearly true, and say yes, because you must go, it's really the sum of any two sides must be, the sum of any two sides must be 1 and the third side. But it's easy if you get the 2 small sides, so I just rewrote that. And now if we do 3 plus 9, question mark, is that bigger than the third longest side? Since 12 is bigger than 14, the answer is no, therefore no triangle. So you want to make sure you reorder the side lengths from small to big. And if you do that and add the 2 smaller ones compared to the third one, the last question is, suppose you have 2 sides in a triangle. Suppose you have 6 inches and 10 inches. You want to find all possible lengths of the third side. Well, we're unsure if the 6 and 10, are they the 2 small sides? Are they the 2 largest sides? Is one the small side and the big side? All right, so it could be blank 6 and 10. It could be 6 blank and 10. Or it could be 6, 10, and blank. And you could play around with it and try to figure it out, but the easy way to do it is, all you have to do is add and subtract, and you'll get the lengths that it can be in between. So 6 plus 10 is 16, and then take the difference between them. 10 minus 6 is 4. So the third side must be in between those 2 side lengths. The third side has to be bigger than 4, but less than 16. It has to be in between 4 and 16. Because if you notice on the first scenario, if the missing side was a small side, well, I need this number. I need the sum of these two to be bigger than 10. So if it's 4, 4 plus 6 is 10, that's not going to work. So it has to be bigger than 4. And on the other end, get rid of this x. This one, 6 plus 10, has to be bigger than this third side if it's the longest side. 6 plus 10 is 16. 16 doesn't work, so this third side has to be less than 16. So practice that with the homework, and you should